So question 8, would a protein with a pI of 6 bind to an anion or cation exchange column as it's run at pH 8? All right, well, our rule is that if the pH is greater than the pKa, or sorry, not pKa, pI, sorry, thinking about different stuff, then basically there's not enough, so at high pH, there's not enough H plus anymore to make the charge be 0. So if our pH is greater than the pI, we don't have enough H plus, and so our protein has a negative charge to it. All right, net negative charge. Now the question is, which type of column will our protein bind to? Well, the name anion or cation exchange column tells you what kind of ions that column binds. So an anion exchange column exchanges anions, meaning it binds anions. Cation exchange columns bind cations. Now, if you get confused about anion cation, well, the way I like to tell my Gen Chem students this is by drawing this little fun guy right here. All right. This is the plusy cat. All right. So cations are positively charged. So negatively charged, if our protein is negatively charged, it is an anion and will therefore bind to an anion exchange column. All right. Now, just to add, kind of review some other stuff. So if anions are binding to the column, what must the charge of the beads be in order to attract anions to it? Well, the beads themselves on an anion exchange column are cations, they're positively charged. All right, so don't get confused about that. Just the easiest way I think to remember this is, the name anion exchange or cation exchange tells you what types of ions that column is binding. And that is it for this problem.